Hi guys, welcome back for another installment of classwork. In particular, we have today our topic is capacitors, batteries, and electric potential, which is voltage, a word that we're going to hear quite a bit more over the next couple of weeks. All right, so what we're going to do very quickly is just talk about really the difference between capacitors and batteries. We're going to find out they're really not that different, and then finally when we have electricity, what causes that? We've talked about electrical force, but we're going to go one step further today. All right, so previously we talked about electricity is the flow of electrons. All right, and so electrons, remember, are outside of the atom, and we have electrons flowing electricity, aka electrical energy, and we have it, say, flow through a light bulb. That light bulb is going to convert that electrical energy into light energy. The light bulb will turn on, okay? And so the question we had previously was, what causes those electrons to flow? And the answer was electrons are pushed or pulled by electrical force, all right? And that followed our fundamental rule. We had likes repel likes, so two protons would repel each other. Opposites attract, so a proton and electron would be pulled near each other. And in the case of an electron, those would push on each other. And when we have a push, that's a force, or pull is a force as well. When we have a force applied over an area, then we get pressure, all right? And so when we have something complicated, that's more complicated than just a single electron, but say now you have, multiple electrons that are not just one electron, wide. There's more than one atom that makes up a copper strand. You have many electrons near each other. In a real life situation, we're dealing with more than just single points. We're dealing with pressure being force over an area. All right, and so as we go forward talking about electricity and electrons moving, we're going to be talking about, a pressure that's causing them to move. And what is that pressure? Well, our in-person classmates are trying to figure that out a little bit, trying to figure out, what are the characteristics of objects that, say, might make it easier for electricity to move. And we've already sort of touched on that a little bit with insulators versus conductors. But what we really have, and what we're going towards over the next week or so, is the relationship between electricity, electric current, the pressure that causes that electricity to move, and the natural resistance to moving electrons that insulators have in abundance and conductors don't have all that much of. All right, so remember, insulators, they hold on to their electrons pretty tightly. And the atoms of insulators, they like to sort of orbit their atoms. Whereas conductors, the electrons, they move freely and easily between atoms, right? So it doesn't take much pressure to get electrons to move in a conductor, and that's part of what our in-person friends are looking at right now. But we need to take the more intellectual approach, which I think is sometimes the more fun approach. All right, so here's a little bit about what the in-person people are doing. We have a capacitor. This is something we touched on Monday and Tuesday. It's our first energy storage device. Right? And we're familiar with batteries as an energy storage device as well, right? We charge our cell phones, we charge our computers, etc. And what we're charging is, a battery. Well, as a capacitor is just two metal plates that you give a negative charge to, and that pushes on the electrons in the other side of the plate and leaves behind a net positive in the other side of the plate. All right, and so when you have a net negative plate and a net positive plate and you connect those two, well, electrons don't like each other, and so there's going to be a pressure, a push over the area of the wire to cause those electrons to move and go from high concentration, high pressure, to low pressure, right, to neutralize the circuit. And as it does that, in this particular instant, we're going to have our light bulb turn on. Okay? And our friends are online. They have, in this little situation, to test whether something's an insulator or conductor, they're putting something in between this loop of metal that's discharging the negatively charged plate into the positive charged plate. And they're finding out is if this light bulb does in fact light up, that means that electrons have successfully gone from high concentration to low concentration. If it does light up, that means that we had a conductor here and not an insulator because electrons successfully moved. All right, and that's a capacitor. Capacitor is just two parallel plates. A battery, as we're going to see for the course of the next week, a battery is actually very similar. In fact, the original battery looks a lot like a capacitor, two metal plates. But we know that batteries are a little bit different, right? Batteries store chemical energy, and eventually they convert that chemical energy into electrical energy. All right? But the basics of the battery are, again, it's just two metal plates, two electrodes, and then it's going to have a conducting material on the inside. All right? Whereas a capacitor has an insulating material on the inside. Interesting. So battery, very similar, but a conducting material on the inside. Capacitor, insulating material on the inside. All right, but they both have the same net effect. When we connect the plate of high concentration of electrons, high pressure, to the plate of, low concentration of electrons, those electrons are going to space out. And so they move through our loop, our circuit. They would turn on a light bulb if they're going through a light bulb. And the plates would neutralize themselves. In the case of the battery, though, because we have a conducting material on the inside, our battery is continuously replenishing this negative charge on, one of our plates. And so the reaction continues, and the light bulb stays lit for a long time, whereas our capacitor is it's a one-time charge, unless you actively recharge it through, say, friction, induction, or contact. But batteries are recharged by the stored chemical energy. All right, we're just about done. In the classwork you're going to do in just a minute, we have a diagram that's going to look a little bit like this. Again, this could be, depending on what's in between our two pieces of metal, this could be a battery or a capacitor. They're very similar. All right. When we have a buildup of negative charges, say on the bottom on one plate, that buildup is what we'd say would be a concentration of electrons, right? That creates an electrical pressure. And what we're really getting to, trying to add some terminology, this concentration of electrons is voltage. So voltage is going to be the word that we use to describe this pressure from high concentration of electrons that causes electrons to move throughout a circuit. Right? Voltage drives electricity to move. And how much electricity moves depends on whether the material it's moving through is it more of an insulator or a conductor. All right. One last thing. If we're talking about stored energy, well, remember, stored energy is potential energy, stored energy due to position. All right. Capacitor stores energy because we know that if we were to put, say, a negative charge near a negative plate, that's a lot of stored energy. It wants to move towards the positive plate. Or if we were to put a positive charge near a positive plate, well, it wants to move towards the negative plate. So when it's near the positive plate, that's a lot of stored energy. All right, say it's that positive charge is now near the negative plate. That's, not very much stored energy, potential energy, all right? But what is a capacitor? What is a battery? There are two methods of energy storage. And it just so happens the difference between the two, well, it's going to be a topic for the next couple of days. They're more similar than different. Pretty cool.